We continue exploring Chinese experience. When we have more tasks than hands, algorithms have to be designed by algorithms. The point is artificial intelligence designing solutions in a cheaper and more accurate way than we do manually, from neural networks to evolutionary approaches. This is the topic of the next speaker's presentation. Professor of Anhui University, Ye Tian, with a presentation on automated design of AI algorithms.
Good afternoon, everyone. I'm a researcher working on the fundamental technologies of artificial intelligence. So today, I would like to share you an emerging topic in the era of fast AI development, that is the automated design of AI algorithms. So my name is Ye Tian, and I'm from Anhui University, which is located in a central city of science and technology in China called Hefei. My research experience includes some AI technologies such as evolutionary computation and reinforcement learning. Also, I have some AI applications in intelligent manufacturing, transportation, and medicine. With the help of AI, I have made some AI-assisted systems such as the assembly line scheduling system and the material topology design methods. So today, my presentation about the design of AI includes 3 parts. The first part is about some introductions to basic AI algorithms. During the development of human, from Archimedes, Euler, tuning to advanced AI methods, people use more and more complex algorithms to solve more and more challenging problems, from the calculation of pi to large language models. With the development of mathematics and computer science, the methods goes from mathematical algorithms, computer algorithms, to the advanced AI algorithms. Currently, AI algorithms have been adopted in many different applications. For example, the image processing, the content generation, the science, the automation, the decision-making, and the design. In these applications, the first 2 applications, image processing and content generation, are highly related to our daily life. Everyone maybe uses them. But for the other applications in biology, manufacturing, and economics, they are also very important to the revolution and the development of the whole society and the industry. So, although these problems are totally from different areas and have totally different objectives, they can be broadly divided into learning problems and optimization problems. The learning problems are to find a function f to make input x and output y satisfy that y equals fx. It's a simple mapping problem. For example, in image processing, the input may be an image observed by a camera, and the output is the label of the image. In content generation, the input may be a description, and the output is the content generated according to the description. In science, the input can be a structure of proteins or materials, and the output is the performance of the structure. And also, in automation, the input can be the current state of the system or environment, and the output can be the next action to be conducted for the system or environment. Also, in optimization problems are to find a solution, the best solution, x, to make a function f optimal. For example, in decision-making, the solution x can be a decision for the program, and the functions can be the profit objectives after making the decision. In design, the solution can be a scheme to be conducted, and the functions can be one or more performance indicators of the scheme. So currently, there have been many methods to solve the learning problems and optimization problems, from mathematical algorithms, computer algorithms, to AI algorithms. Currently, in AI, the most representative methods are neural networks and evolutionary algorithms for solving learning problems and optimization problems, respectively. The neural networks are inspired by neural connections in brains. They can act as a function f to learn the mappings between input and output. Some popular neural networks, such as fully connected neural networks, non-short-term memory, convolutional networks, transformers, and diffusion models. Also, evolutionary algorithms are inspired by the biological evolution in nature. They can iteratively search for the best solution to make a function f minimized or maximized. For example, there are some popular evolutionary algorithms that include genetic algorithms, particle swarm optimization, differential of evolution, ant-colony optimization, and the multi-objective optimization algorithms. So, compared with other mathematical methods and computer methods, these two AI algorithms have their advantages in solving very complex learning problems and optimization problems. For example, for neural networks, they have the abilities of nonlinear model and data-driven learning. As a higher nonlinear model can be obtained to learn the complex mappings between input and output in the chaotic real world. Also, only data is required to train a model where domain-specific knowledge is unnecessary. On the other hand, for evolutionary algorithms, they have the abilities of multi-objective optimization and black box search. It means that for evolutionary algorithms, they can optimize multiple objectives and constraints simultaneously without the need for combine them into a single one. Also, only function evaluation is required to search, where the domain-specific information is unnecessary for evolutionary algorithms to search. So there have been many variants of neural networks and evolutionary algorithms. As a neural network architecture has many components and parameters to tune. For example, the type of layer, the collections between layers, the parameters of layer, and the training configurations. Also, for evolutionary algorithms, they also have many components and parameters to tune. For example, the type of operator, the collections between operators, and the parameters of each operator. So here's an important question comes. How can we tune the parameters and components of neural networks and evolutionary algorithms? Or on the other hand, in other words, can we find the best components and parameters for neural networks and evolutionary algorithms? So the answer is no. We cannot find a single neural network or evolutionary algorithm to solve all the problems. This is because of the so-called low free lunch theory. This theory has been theoretically proved. It's correct. It says that all algorithms perform equally well when averaged over all possible scenarios. Unfortunately, it means that we can only find the best components and parameters for each scenario. And the best components and parameters for different scenarios may be very different. That is, we cannot have a single AI algorithm to solve all the problems with the best performance. In practice, AI algorithms can automatically solve problems, but AI algorithms themselves are manually designed by AI researchers and programmers. The design of AI algorithms is not easy because it requires heavy expertise, novel innovation, laborious experiment, and expensive cost. It's a very difficult and challenging problem. So here another very challenging question comes. Can AI algorithms be automatically designed for different scenarios so as to reduce the expensive requirements in the design of AI algorithms? So the answer comes to the second part of my representation, is the automated design of AI algorithms. In general, the use of AI algorithms is labor-intensive, since AI experts and problem domain experts need to perform algorithm selection, component compilation, and parameter tuning, and also the algorithm performance evaluation many times, so that they can get a good AI algorithm with good components and parameters to be used in different problems. With this case, we can use the automated design methods to automatically generate new AI algorithms. The automated design is a higher level of automation, as it can totally make the expensive procedure totally automatic. In other words, we can use computers to design totally new AI algorithms instead of human experts. The automated design has several advantages. The first one, it can improve the development efficiency. The automated design of AI algorithms reduces the requirements of expertise, innovation, experiment, and cost. Second, the automated design methods can improve the algorithm performance, because the automated design AI algorithms can be better than those designed by humans. They can break through the design limitations of human experts. Third, it can improve the cross-domain transferability, since the AI algorithms designed on existing problems can be adaptively transferred to be used in other problems. Generally speaking, it seems that the existing AI algorithms is good enough in many applications, such as large language models and content generation, as well as the playing golf. But in fact, these applications need a large number of data sets to fully train the neural networks or searched by evolutionary algorithms. However, in many other scenarios, we cannot get such a large number of data sets, especially in the applications in industry and manufacturing. In this case, we should have the automated design methods to design more effective and more efficient AI algorithms automatically to break through the limitations of human. So the issue comes to what to design, where can it be used, and how to design. As for what to design, the automated design methods can achieve the combination of components, the tuning of parameters, and the creation of totally new algorithms. As for where it can be used, the automated design methods can customize new evolutionary algorithms for solving optimization problems, and customize new neural networks to solve any learning problems. As for how to design, in fact, the automated design methods are also based on existing AI algorithms. That is, we can use existing AI algorithms to generate more effective and more complex new AI algorithms. AI algorithms can develop and evolve themselves. Then I would like to introduce some representative automated methods for the design of neural networks. For example, the parameter tuning aims to tune the parameters of a neural network. The architecture search aims to find the best architecture of neural networks. And the network quantization aims to find the best quantization bits for neural networks. Also, the prompt optimization aims to find the best prompt text for large language models to be used. As can be observed, all these automated design methods are in fact learning problems, are in fact optimization problems. That is, this task aims to find the best parameters, architectures, quantization bits, and the prompt text. Therefore, these automated design tasks can be handled by existing optimization algorithms. For example, the existing evolutionary algorithms, Bayesian optimization, gradient methods, and heuristics. Next, I would like to introduce some automated methods for the design of evolutionary algorithms. For example, the algorithm selection aims to select the best evolutionary algorithm for each problem. The component combination aims to switch between different components in an evolutionary algorithm. The parameter tuning aims to find the best parameters for an evolutionary algorithm. And also, the algorithm creation aims to create totally new algorithm source codes for new problems. The first two tasks, algorithm selection and component combination, they are in fact learning problems. They in fact aims to learn the mappings between the best components and the problem features. Therefore, they can be handled by existing learning algorithms. For example, the supervised learning and reinforcement learning based on neural networks. On the other hand, the parameter tuning and algorithm creation are in fact optimization problems, as they aim to find the best parameters and algorithm source codes for each problem. Therefore, they can be handled by existing optimization algorithms. For example, the evolutionary algorithms and the generative model-based search. In the third part, I would like to introduce some representative applications of the automated design of AI. The first application is biological sequence analysis. This problem aims to build models for biologists to analyze, evaluate, and create new DNA, RNA, and other biological sequences. It's an important learning problem in the field of biology, where the input can be the biological sequence and the output can be the analysis result of the sequence. However, this problem is very challenging because biologists lack AI expertise to build effective neural networks to biological sequence analysis. Therefore, automated design methods can be used to automatically find the neural networks, to automatically find the neural architectures and tune their parameters to achieve the best performance of neural networks for biological sequence analysis. The second problem is edge AI. It aims to process images using neural networks in edge devices with limited computational resources, not the large computers. It's a typical learning problem in the field of deep learning, where the input can be images of users and the output can be the labels of the user. It's also a challenging problem because edge devices cannot run large neural networks due to the limited memory and the GPU performance. So it requires a balance between efficiency and performance. Therefore, automated design methods can also be used to automatically find suitable quantization bits for the neural networks used in different edge devices so as to reduce the computational complexity of the neural network and make it run more efficiently and reduce the requirements of hard devices. The third problem is mathematical discoveries. It aims to discover new mathematical algorithms for solving challenging problems. It's a typical learning problem in the field of mathematics, where the input is a problem statement, and the output is the source code of the new algorithm to solve the problem. This problem is difficult since large language models suffer from confabulations and make plausible but incorrect statements, and the problem cannot be solved. Therefore, automated design methods can be used to automatically revise the prompt text of large language models to make it generate better and better source codes so that to solve the problem better and better. The fourth problem is assembly line scheduling. This problem aims to find the best production sequence for giving orders in assembly lines. is an important optimization problem in the field of manufacturing, where the solution can be a production sequence and the functions can include the lower production time and the lower production cost. This problem is also not very easy, since multiple evolutionary algorithms are effective for handling different constraints in different assembly lines for different scenarios. Therefore, we can also use automated design methods to automatically select the best evolutionary algorithm according to constraints in advance, so that we can more effectively solve different assembly line scheduling problems in different scenarios. The next problem is the structure design. This problem aims to find the best structure of vehicle components based on finite element analysis and evolutionary algorithm. It's also an important optimization problem in the field of manufacturing, where the solution can be a two-dimensional structure, and the functions contain lighter weight and higher stiffness of the structure. This problem is difficult because multiple solution representations are effective for different geometric structures. To address this issue, automated design methods can be used to automatically switch between multiple representations during the optimization process of evolutionary algorithms, so that it can make the evolutionary algorithm use the best representation all the time. The last application is radiotherapy planning. This problem aims to find the best therapeutic field of electron accelerators for each patient based on evolutionary algorithms. It's a very important and challenging problem in the challenging optimization problem in the field of medicine, where the solution is an aperture shape and the functions contain the higher dose in tumor filled with cancer cells and the lower dose in organ filled with health cells. This problem is difficult since existing evolutionary algorithms are not efficient enough to solve this problem, where the patients are waiting for the plan and they cannot wait for too long. Therefore, we can use automated design methods to automatically design new evolutionary algorithms with better efficiency for radiotherapy planning. Well, in the near future, neural networks and evolutionary algorithms are currently the mainstream methodologies of AI. As we can observe from the reports published by different countries, the terms like neural networks, genetic algorithms, evolutionary computation can be widely observed from these reports. Meanwhile, the automated design methods exhibit a bright prospect in the development of AI, where the terms like automated machine learning, automated design of meta-heuristics just means evolutionary algorithms and something else, and also the automated large language model architecture search. These terms can also be widely observed from the reports. The automated design of neural networks and evolutionary algorithms are very popular in the academic community, as can be observed from the higher figure. The paper with automated neural network or automated evolutionary algorithm increased significantly in recent years. Also, the researchers pay more and more attention on the automated design of AI, as can be observed from the lower figures. The projects with automated neural network or automated evolutionary algorithm in a region also increased significantly in recent years. So as a result, I think the automated design methods of AI is very promising and can change the paradigm of the AI development in the near future. And unfortunately, the demand of more effective automated design methods is urgent, since currently the performance of existing automated methods are still far from satisfactory. So we should make effort on the AI theory, method, as well as hardware simultaneously. First, we need a unified framework to make the parameterization and representation of AI algorithms more easily. Second, we need an effective method to accelerate the search and evaluation of promising AI algorithms. Lastly, we need powerful hardware to improve the efficiency of the expensive automated design process. So That's all my talk. Thank you very much for your attention.
Thank you, Professor Ye Tian. Thank you.
Thank you.
Thank you. Thank you for such a deep dive in this topic. Thank you very much, and we wish you a great success in your future science and your future experiments.
Yes. Thank you very much.
Thank you.
Okay.
Maybe anyone has a question in the audience?
Professor, thanks a lot for interesting presentation. Talking about the thing that you're probably trying to tell, that you need different approaches to train models. Don't you think that entire approach might be in the different field that is like philosophical understanding of the roots of wisdom, which makes us think in the right direction, might be as different as understanding of the things you're trying to say? Like, we have classical models and we need to train them in a different way. But shouldn't we first understand entirely different thing of where we should go? So I mean, the paradigm shift required to train what we have as classical models. I hope that that's more or less clear, or at least just give your answer to the way you understood my question. Thanks a lot.
Okay, thank you very much for your great question. It's a very good opinion about the future development of AI. Personally, I think currently the neural networks and evolutionary algorithms and also some other technologies are still the mainstream technologies in AI. At least in the near future, we cannot make totally different AI technologies. So we can only to create new, for example, new evolutionary algorithms and new neural networks based on existing ones. So they may be very similar to some existing ones, but they can be automatically designed that can break through the design limitations of human. For example, some parameters, if human experts to set the parameters can be 1, 2, 3, 4, 5. But we use automatic design methods. The parameters can be, for example, 1.1, 2.2, 3.4, some not integers. These parameters and other components cannot be found by human because of the expensive procedure of manual design. So we can use automatic design methods to save many experiment cost, expertise, and the time in the design of AI algorithms. Of course, we cannot use these methods to find a totally new AI algorithms that are totally different from existing ones, unless we have make a framework that is totally different from existing ones. In this case, we use the totally new framework, and we can find a totally new AI algorithms. I think this is the way we can do. Thanks.
Thank you. Thank you for our audience for the questions. And thank you, Mr. Ye Tian, ваши аплодисменты. Ну, а мы движемся.
Mr. Ye Tian, thank you.